Hey guys, I hope you're all doing really well this week. This is a HP laptop that I bought for 30 euros from a guy on a secondhand site. He says that he was just working away on it one day and it stopped working and it no longer powers on. So the power button is on the side here. It's a discreet little thing. You can see it here. So if I push it, you can see me pushing it in there and nothing happens. This didn't come with an adapter. However, I do have an adapter from another HP. And when I plug it in here and then press the power button, so I'm pressing it now, we're still not getting anything. Now, one thing I did notice is that there seems to be damage here. I didn't notice this when I took it from him. But see the way that seems to be moving up and down here. And there is a little bit of an opening there where the jack comes in. So it may just be an issue with the jack. But what I'm going to do is I'm going to take it apart and we're going to get a look at it from there. I'm going to carry out an initial visual inspection of the motherboard. I've taken the motherboard out of the laptop and I've scanned it in just so that I can bring you guys along with me. So this is our BIOS battery here. So let's zoom in a bit and see if we can spot anything. That's our DC power jack. Okay, one thing I did notice was a small little mark here on this inductor, but I think that's just where the red pen came across. Somebody marked this with a red pen. I think they hit that there, but it's nothing to worry about. Okay, so do you see anything there at all? If you do, you're very welcome to put it down into the comments, but as of now, I've had a good look at this board and I don't see anything wrong. That's the power connector for the power button right there. I don't see anything wrong with any of the components just from a visual inspection here, so I'm going to flip it over and take a look at the other side of the board. This is the other side of the board, so we're going to continue our visual inspection. Everything looks okay there. Okay. Like I said, if you spot anything here, you're welcome to put it in the comments down below, but I'm not seeing anything that looks like it's blown. Okay, so everything looks okay. So what we're going to do is we're going to plug in the adapter and we're going to start tracing where the 19 volts goes from there. Now, we saw in the first part of the video that it seemed like there was a bit of damage to the laptop at the section of the laptop where the DC port is. So I just want to confirm that we're getting the correct voltage onto the motherboard from that DC jack, and then just trace and see how far that's going into the laptop. So I place my multimeter into the 20 volt DC range because we're expecting about 19 or maybe a little bit more, and then I connect my black probe to ground and I place my red probe to the input pin. Now, how do I know which one of these is the input? Well, I'm looking at this. There's 8 wires I think come on to this little connector here. And if I look, I can see the red wires here. If you see the red wires here, that's usually an indication that's where the positive voltage is coming in. So I place my probe here and I measure and I find that there is 19.6 volts at this point. Now, as you can see, when we zoom in a little bit, there's no other components here. It's just on this track here. So what's going on? Well, what appears to be happening is that our 19.6 volts is carried along this section here, and then there are 2 vias right here. So it's carrying that 19.6 volts through to the other side of the board. So let's follow it through to the other side of the board and see if we can work out where it's going. Okay, I flipped the board and I spotted where that via comes through to the other side. So I'm pretty sure it comes through to here. So what I'm going to do is I'm going to take some more voltage measurements. I'm going to place my black probe to ground. I'm still in volts DC, and when I measure at this capacitor right here, I find that there is 19.6 volts at this point here. So that's definitely where the 19 volts comes through to the other side of the board. Okay, so I'm continuing to mark in where our 19.6 volts is coming, and the next components in line are these 2 inductors right here. So we've got PL2, that's power inductor 2, and power inductor 1. So these very rarely fail, so I again take a voltage measurement here and I find there's 19.6 volts on the other side. Now, as you can see, the track carries that 19.6 volts down onto these 4 pins of this IC right here. So just to confirm it, that there's no cut in the track or anything, I place my probe here, and again in volts DC I measure, and I find that my 19.6 volts is making it to these 4 pins of our MOSFET here as well. The next component in line is this right here. So this is a 6414A, and I found a data sheet for that. So that is an N010DX 30 volt N channel MOSFET. Now this is used to control the input of the 19.6 volts into the system. We're measuring 19.6 volts on our drain pins right here. So there's a gate pin on this which controls whether that 19.6 volts is allowed from here across to the source pins or not. So what we should be expecting to find is that if that gate pin is high, maybe about 23, 24, 25 volts, that the MOSFET is switched on and we will find 19.6 volts at the source pin. So what I do is, once again in volts DC, I place my red probe to the source pin, any one of the source pins, and I find that there's 0 volts here. And similarly, when I place my probe to the gate pin, which is right here, there is also 0 volts on this. So this is where our issue is. Well, it's not necessarily where our problem is, but this is where the 19 volts stops. On a working laptop, that 19 volts should be coming through the 2 of these, and then our main power rail is the rail down here. But for some reason the system is not happy to allow this MOSFET to turn on, so we may find that there is a short somewhere else on the board. So before going any further, I wanted to just check and see if there was an obvious short anywhere around this area, maybe between these 2 MOSFETs or maybe on the main power rail. So what I did was I plugged the laptop out, and then I switched my digital multimeter into diode mode, which looks like this on mine. And this time I placed my red probe to ground, and then my black probe I then use to take measurements. I first measured at the source pins of the first MOSFET. So when I placed my probe here, I found that it was measuring 0.562. Now that is not shorted, that is an expected reading, so there doesn't seem to be any short at this point. Next I want to measure to see if there's a short after the second MOSFET. So we've got MOSFET 1 here, which is the AC FET, MOSFET 2 here, which is the RB FET, and then this should be the main power rail. And I place my probe here, once again in diode mode with the adapter plugged out, and what I measure here is 0.005. So what do you think of that? Well, that's a very, very low value, and it looks to me like it's a short. So it seems that we have a pretty common fault, that there's a short on the main power rail. So what we need to do next is to inject voltage to try and flush out whatever component is shorted. And I'm going to set that up next. So we need to inject voltage into our main power rail to try and flush out what is actually shorted. So I introduce my DC power supply. I connect my black wire to a ground, and I decided to scratch away a bit of the track here and connect my red wire to this here. It just wouldn't connect to this MOSFET for whatever reason, so I'm injecting here. And I started off by injecting half an amp at 1 volt. Now with such a low voltage and such a low current limit, nothing was heating up on the circuit. So when I tried to increase the current level, it wouldn't increase because the voltage was too low. What I found was I had to increase the voltage quite a bit, and I increased it up to 9 volts, and when I did that it pulled 0.8 of an amp, and when it did that, certain parts of the board started heating up, and I'm going to show you that now. I've taken this short video with my microscope, and you'll see I'm just dousing it in a bit of flux here, and you'll see when I inject the voltage what happens. So I'm just about to switch it on now, and you can see straight away it's fried. So this looks to be the component that is shorted. So what I'm going to do is I'm going to take a look at that on my high quality image. This is the IC that we observed burning on the previous section of this video, so this appears to be shorted. This is a battery management IC, BQ715. So just to go back over what we've done in this video, first of all we observed that we were getting 19 volts at the DC jack, so there was nothing wrong with the DC jack, which I originally thought might have been dodgy. So we're getting our 19 volts onto the motherboard. We observed that 19 volts was coming through 2 inductors onto the first MOSFET, but not getting any further than that. Then next we questioned why was it not getting any further than that. So I tested for a short, and I found that there was a short on the main power rail. And when I injected voltage onto the main power rail, this started burning. So what I'm going to do is I'm going to try and source one of these BQ715s. There's no guarantee that this is the only thing that's blown on this, but what I'm going to do is I'm going to replace this and see where we take it from there. That's all I got for this week, guys. I just want to say thanks to all of the 997 people who have subscribed so far, and hopefully we'll push that over to 1k during the week. I will be back with something else next week. Please keep watching and leave any comments below. Thank you.